Statistical intervals for a single sample. The course outcomes that would be resolved by this topic would be application of statistical methods in the analysis of data. While for the intended learning outcomes, the students are expected to construct confidence intervals on the mean of a normal distribution using either a normal distribution or the t-distribution method. Construct confidence interval on the variance and standard deviation of a normal distribution. Construct confidence interval on a population proportion, and use general methods for constructing an approximate confidence interval on a parameter. Estimating the mean. The first of the ways of estimating the population mean would be the confidence interval on the mean with the variance known. So when we say the variance is known, sigma squared is given on the problem. So it can be a sigma or a sigma squared. Sigma is the standard deviation and sigma squared is the variance. Take note of the population. So it was noted that the variance of the population must be known. So if x bar is the sample mean of a random sample of size n from a normal population with known variance sigma squared, a 100 times 1 minus alpha percent confidence interval on the mean is given by x bar minus z of alpha over 2 times sigma over square root of n. While for the upper limit, it would be x bar plus z of alpha over 2 times sigma all over square root of n. So when z of alpha over 2, where z of alpha over 2 is the upper 100 times 1 minus times alpha over 2 percentage point of the standard normal distribution. So if we want to calculate n, the sample size, um, we can vary the equation such that if x bar is used as an estimate of mu, we can be 100 times 1 minus alpha percent confident that the error x bar minus mu will not exceed a specified amount e. So x bar minus mu is the error e. When the sample size is, so in computing the sample size n, we have z of alpha over 2 times sigma over e quantity squared. Now take note that we round it up so that we will be more confident rather than less confident. So if this is the true population mean mu, there is an approximate value x bar. So we limit the error so that we will be 1 minus alpha confident. So for one-sided confidence bound on the mean and variance is known, we don't divide alpha by 2 anymore because we allot the error to be on one side. So a 100 times 1 minus alpha percent confidence bound, upper confidence bound for mu is, so upper would be the plus side and then the lower would be the minus side. So x bar minus would be the lower confidence bound and x bar plus would be the upper confidence bound. And we don't divide alpha by 2 anymore because this is a single-sided confidence interval. The large sample confidence interval on the mean, when we say the when the variance is unknown, if the sample size is relatively large, meaning um, n is much larger than what we have, we can use the formula for z to be equal to x bar minus mu over s divided by square root of n since we don't know sigma. So if we don't know sigma, we can have x bar minus mu over s divided by square root of n. So this is still a z distribution if the sample size is large enough. So, using the standardized normal distribution, let us solve the following. What is the confidence level for the interval um, mu is in between x bar minus 2.14 sigma over square root of n up to x bar plus 2.14 sigma over square root of n. So for this problem, what we want to do is to solve for the probability of, this is the upper limit, 2.14 minus, for the lower limit, it would be negative 2.14. So for letter A, so this is 0.96764. For letter B, um, it would be the probability of the upper limit 2.49 minus for the lower limit negative 2.49. So this would give us 0.98722. For letter C, it would be from negative 1.85 to positive 1.85. So this would be P of 1.85 minus P of negative 1.85. So this is 0.93568. For letter D, so it would be less than 2. So less than 2 would be P of 2. So this would be 0.97725. Now, there is a difference if we're going to have it from the other side. So, paano pag, if we will now be given with the probability and then we're looking for the value of z. So, for number 2, for second part, 1 minus alpha is 0.98. So, that would give alpha to be equal to 0.02 or alpha is 0.01. So for this one, Z is what would give us an area of 0.01. So I think it would be 2.33. So this would be plus or minus 2.33. For letter B, so for zero point 0.8, so 1 minus alpha is zero point 0.8, alpha is 0 0.2, so alpha over 2 would be 0.1. So Z is, you can check on your table, I think it is under negative 1.28. So it would be plus or minus 1.28. I think there's letter C. So this is 1 minus alpha is 0.75. So alpha is 0.25. Alpha over 2, 0.125. So to solve for that, 0.125, we check the table. It is 1.15. So we use Z to be plus or minus 1.15.